Good morning. Today we will go through the domestic wiring module. So first, let us see why do we need wiring. Wiring is required in the construction of either residential or commercial or industrial properties. Proper wiring will enable the installation of different electrical appliances. So here in this module we will discuss different types of wiring methods, earthing methods and also other related issues. So first, let us see the factors affecting the selection of wiring method. First, electrical safety. The wiring should be such that it does not pose any danger or there won't be any problem of electric shock. Also, no leakage of current. Secondly, mechanical immunity. The wiring should be protected from any kind of physical damage. Third, the permeance. The wiring should not be deteriorated because of environment factors such as dampness. Fourth, appearance. The appearance of the wiring does make a difference in the case of house or maybe offices. But in the case of factories or godowns, appearance is usually not important. Apart from the above discussed factors, we also need to keep the economy or the cost in consideration. So next, let us look into the topic of service connection or service means. So first, let us understand what do you mean by service connection or service means. The line bringing electric power from the distributor up to the energy meter installed at the consumer's premises is called service connection or service means. So this is a service connection diagram. So let us consider a house here. Service connection is given to a house through a GI pipe. The service connection is brought from a nearest distribution pole to a shackle insulator. So you can see the shackle insulators here. The wires are wound on these shackle insulators, which are located at a suitable height. So the main supply is delivered to houses using a 3-core wiring called the live, neutral and the earth. So here you can see our diagram. You can see how the service wire is brought from the distribution pole to your house, and from your house it goes to the different appliances which are present in your house. So you can see here in the second diagram also how the connection is going to the different parts of your house. So now we have already seen how the connection is done until the meter board. Let us see what happens next. Once the supplier service lines are brought to the consumer's premises, then they have to be connected to the consumer's internal wiring. The consumer is charged for the amount of electricity used, and hence the supplier service lines are connected to the input terminals of the energy meter. So you can see here the incoming cable is given to the energy meter so that the supplier can charge the consumer for the electricity used. From the energy meter, the connection is then gone to the cutout. The cutout contains a fuse which will enable the electricity supplier to discontinue or cut off the electricity supply if the consumer fails to pay electricity bill. Cutout and the energy meter is the supplier's property. From the cutout, the connection is then given to the main switch. Main switch will be accessible to the consumer so that the consumer can switch off the supply whenever required. From the main switch, the connection is then given to the distribution board, which enables supply to various utilities like fans, light and other appliances. So next, let us see two different ways of controlling a lamp. So we have got two ways. One is the two-way control of lamp, where you're going to control one lamp using two different switches. The second one is the three-way control of lamp, where you are going to control one single lamp using three different switches. First, let us go through to the two-way control of lamp. Let us consider a wiring diagram to control one lamp using two switches. So let me consider a case where a person wants to go from the ground floor to the first floor. And let me consider that there is a lamp on the stairs. So when the person intends to go up to the first floor, the light needs to be switched on. So the person uses this first switch which is present on the ground floor, switches on the lamp. The person goes up, reaches the first floor. He no longer needs the lamp, so he switches it off using the second switch which is present on the first floor. Same way, let me consider that the person wants to come down now. Again, he needs the lamp, so he switches it on using the second switch which is present on the first floor, comes down. He no longer needs the lamp, so it switches it off using the second switch which is present on the ground floor. So you can clearly see one lamp controlled using two different switches located at two different positions. So this is how a two-way control of lamp operates. So let me consider a circuit here. Let me analyze different positions of the switch and let me check whether the lamp will be on or off. First case, let me consider that the switch S1 is connected to position 1 and switch S2 is connected to position 3. What happens then? Whether the circuit will be complete? So you can clearly see the circuit becomes complete and the condition of the lamp will be on. Second case, let me consider that the switch S1 is at position 1 and switch S2 is at position 4. The connection or the circuit becomes incomplete and the lamp will be off. Third case, switch S1 is connected to position 2, switch S2 is connected to position 3. In this case, again, the circuit becomes incomplete, lamp will be off. Fourth case, switch S1 is connected to position 2, switch S2 is connected to position 4. Again, in this case, the circuit becomes complete and the condition of the lamp will be on. So this is how one single lamp is controlled using two different switches. That is the two-way control of lamp. Next, let us see three-way control of lamp. Sometimes in a very big corridor or workshops, it may be necessary to control a lamp from three different points. In such cases, the circuit connection requires two two-way switches and an intermediate switch as shown above. So here, so you can see you have switch S1 and switch S2 and an intermediate switch here in the middle which has four different terminals C, D, E, F. Now again, intermediate switch can have two different types. That is, intermediate switch has four terminals, so it can be connected from C to D, E to F. In this case, it is said to be connected in the straight connection. It can also be connected in another type, where CF and ED is connected, so the intermediate switch is said to be in the cross connection. So let me first analyze a three-way control of lamp where the intermediate switch is connected in a straight connection. So first let me take that switch S1 is connected to position A and switch S2 is connected to position G. So what happens then? Will the circuit be complete? Will the lamp be on or off? So when the switch S1 is connected to position A and switch S2 is connected to position G, in this case the whole circuit will be complete and the condition of the lamp will be on. Similarly, when the switch S1 is connected to position A and switch S2 is connected to position H, in this case the circuit becomes incomplete and the lamp will be off. Third case, when the switch S1 is connected to position B and switch S2 is connected to position G. Again, in this case, the lamp will be off. Similarly, fourth case, where switch S1 is connected to position B and switch S2 is connected to position H. In this case, again, the circuit becomes complete and the lamp will be on. Now let me consider the second type, where three-way control of lamp is connected in a way where the intermediary switch is connected in a cross connection type, that is from C to F, E to D. So let me analyze the four positions now. Switch S1 is connected to position A and switch S2 is connected to position G. The circuit becomes incomplete and the lamp will be off. Switch S1 is connected to position A and switch S2 is connected to position H. The circuit becomes complete and the condition of the lamp will be on. Third case, when switch S1 is connected to position B and switch S2 is connected to position G. In this case again, the circuit becomes complete and the condition of the lamp will be on. Fourth case, switch S1 is connected to position B and switch S2 is connected to position H. In this case again, the lamp will be off. So this is how one single lamp is connected using three different switches. So let us go to the next topic. Types of wiring. So we have several types of wiring, several different types of wiring. So first one is the cleat wiring. Then you have CTS wiring or TRS wiring or the batten wiring. Then we have metal sheet wiring, casing and capping, and conduit wiring. So we will see what are these different types of wiring, how are they connected. First let us go to the cleat wiring. Now in this type of wiring, insulated conductors are supported on porcelain or wooden cleats. The cleats have two halves. You can see here it has got one base, one cap. The cables are placed in the grooves provided in the base and then cap is placed. Both are fixed securely on the walls by 40 millimeter long screws. The cleats are easy to erect and are fixed 4.5 to 15 centimeters apart. This wiring is suitable for temporary installations where cost is the main criteria but not the appearance. The next type of wiring is the CTS or the cable tire sheet, TRS or the tough rubber sheet, or the batten wiring. In this type of wiring system, wires sheathed in tough rubbers are used which are quite flexible. So you can see here. You can see the wires sheathed in this rubber. They are clipped on wooden battens with brass clips and fixed onto the walls or ceilings by flat head screws. These cables are moisture proof. They are suitable for damp climatic conditions. Next type of wiring is the metal sheet or lead sheet wiring. Here, the conductors are individually insulated and covered with a common outer lead aluminium alloy sheath. So you can see different conductors individually insulated. The sheath protects the cable against dampness and mechanical damages. The sheath is earthed at every position to provide a path to ground for the leakage current. They are fixed by means of metal clips on wooden battens. This type of wiring system is very expensive. Next type of wiring is the casing and capping. It consists of insulated conductors laid inside rectangular teak wood or PVC boxes having grooves inside it. So here you can see a wooden box. A rectangular strip of wood called capping having same width as that of casing is fixed over it. So it has a base, again it has a cap. Both the casing and capping are screwed together at every 15 centimeters. Casing is attached to the wall. The system is suitable for indoor and domestic installations. The next type of wiring is the conduit wiring. So conduit can be made up of welded tubes of steel or galvanized iron. So insulated conductors are carried inside this conduit tube. These tubes are then routed along the walls and ceilings and are rigidly secured by fixing them with bolts and screws. So you have got two types of conduit systems. One is the open conduit and another one is the concealed conduit. So first let us see what is open conduit. So here you can see an open conduit figure. So what happens here is the insulated conductors are taken inside this conduit and then these conduits are fixed to the outside or the plastering of the walls. So you can see here clearly these conduits are visible. So when it comes to the appearance, it doesn't look that good. So this is the open conduit system where the conduits are directly fixed on the outside of the walls. So next we have concealed conduit. So difference between the open conduit and the concealed conduit is, in the open conduit, the conduits will be fixed to the outside of the wall, whereas in the concealed conduit, these conduits will be placed inside the walls and will be hidden from view. So these will be embedded within the plastering of the walls. So let us see the different advantages and disadvantages of this conduit wiring. So first let us go through the advantages. So since the conductors are placed inside the conduits, we can protect the conductors from the mechanical injury. We can protect it from any of the atmospheric gases. Also, they can be easily available for alteration and repairs. The disadvantage is that skilled workers are required for this. Also, whenever these conduits are placed in the dam situations, water will condense inside the tube. This is the disadvantages of the conduit system. So let us see then other topics tomorrow in the next class. Thank you.